Thank you very much. Let me begin with my background as instructor of teaching seismic anisotropy. I currently teach 2 courses on seismic anisotropy, one with Colorado School of Mines Professor Ilya Svankin for SCG. This is a 2-day course. We began teaching it in 2002 and taught it over 50 times by now at all continents except for Africa and Antarctica. The second course that I am teaching also on seismic anisotropy, it is EEG course. It is a 1-day course, and I taught it about 20 times by now in countries of former Soviet Union, but also in the United States and Argentina. The course I will be teaching for Petro-Teach is different from those 2. It is a longer course. It is a 5-day course, while those 2 are 2 days and 1-day courses, which means that I can put much more my experience in this course and cover more material. The Petro-Teach course contains roughly 3 big blocks. The first is theory that I cover pretty thoroughly, theory about seismic wave propagation in anisotropic media, theory of inversion, of which quantities we need to target in our inverse algorithm to get information about rock properties, about fluids, about fractures. Then the second block contains applications of all those techniques to standard reflection data. There we will discuss conventional P-wave data as well as multi-component data and such subjects as fracture characterization from seismic reflection data. The third block is new. I don't cover it in my other 2 courses. It focuses on microseismic monitoring for hydraulic fracturing. This is a relatively new technique that emerged about a decade ago, and anisotropy plays an important role there because we stimulate shales which are intrinsically anisotropic, and we fracture them, adding to anisotropy. Perhaps the most exciting part of this third block is the ability to image reservoirs with downhole microseismic data at a very high resolution. So we are talking about resolution about an order of magnitude greater than resolution in our typical seismic reflection data. So this is what participants of the course are expected to learn, and also, we will have exercises in this course, both hands-on exercises and theoretical exercises, and I will be discussing numerous case studies, both from seismic reflection data and microseismic data. The main learning objective of the course is to expose the participants to various manifestations of seismic anisotropy in rocks and teach them of how to extract parameters that describe this anisotropy and how to relate it to rock properties, to fluids that are produced from petroleum reservoirs, and to fractures, which are also of interest. But I'm going to to give the sense to the participants of the variety of applications of seismic anisotropy, and then it will become up to them to develop the software for those applications. And I am going to describe what it is available today and what can be done with various seismic data and how it can improve the ability of companies to explore and exploit hydrocarbon